Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on February 13th, 2026, about 4 days ago. It introduces a comprehensive benchmark called SkillsBench, revealing that while curated procedural knowledge can boost agent performance by roughly 16 percentage points, models struggle significantly to generate these skills on their own. The paper is titled SkillsBench, Benchmarking How Well Agent Skills Work Across Diverse Tasks. And as we'll see later, the detailed breakdown of where these skills succeed and fail offers some really crucial insights for future model development. Alright, Figure 1 maps out the agent architecture and the headline results. The top diagram illustrates their conceptual stack. Base models act like CPUs, the agent harness functions as the operating system, and skills serve as the applications. Below that, the bar chart reports resolution rates across 7 configurations. You can see a clear trend here. The darker bars, representing curated skills, consistently outperform the lighter baselines by over 16 percentage points on average. In contrast, the hatched bars show that self-generated skills offer little to no benefit, often matching the baseline. Well, to understand what sets this approach apart, Table 1 compares skills against standard methods like prompts, retrieval-augmented generation, and tools. You can see in the central rows that while retrieval-augmented generation provides data and tools offer functions, neither inherently includes procedural guidance, the actual know-how. The skills column on the far right, however, satisfies all criteria. It shows that skills uniquely combine this modular guidance with executable resources, giving the agent both the instructions and the assets it needs. So, having established what skills are, Figure 2 outlines the entire SkillsBench pipeline. On the left, Phase 1 shows the construction process, where the team aggregates over 47,000 unique skills and collects hundreds of task submissions. Next, the middle panel illustrates the strict quality filtering in Phase 2. Here, a combination of automated checks and human reviews whittles the pool down to just 84 verified tasks. Finally, Phase 3 on the right details the evaluation, where agents like Claude Code and Gemini CLI execute over 7,000 trajectories to measure success. Moving to the results, Figure 4 plots the Pareto frontier of pass rate versus average cost per task. The vertical axis tracks success, while the horizontal axis shows cost on a logarithmic scale. You can see 2 distinct curves here, the red dashed line for agents equipped with skills and the blue dotted line for those without. Crucially, the skills curve sits consistently higher, meaning agents achieve better results for every dollar spent. In fact, smaller, cheaper models like Claude Haiku 4.5, shown on the far left, when boosted by skills, can actually outperform the baseline of much larger, more expensive models. Okay, while the previous figure showed the aggregate benefit, Table 4 breaks down efficacy by domain, revealing huge variance. At the top, sectors like healthcare and manufacturing see massive gains of over 40 percentage points. Manufacturing is particularly striking because without skills, the pass rate was just 1%, but with them, it jumps to nearly 43%. Conversely, domains like mathematics and software engineering show much smaller improvements, around 4 to 6 points. This implies that skills are most valuable in specialized fields where the model's native training data is likely sparse. So, moving from where skills work to how many you need, Table 5 analyzes the optimal quantity per task. The data reveals a sweet spot. Providing 2 to 3 skills yields the maximum benefit, boosting pass rates by 18.6 percentage points. In contrast, the bottom row shows that when agents face 4 or more skills, the performance gain collapses to just 5.9 points. This sharp decline suggests that piling on too much procedural information creates cognitive overhead, essentially confusing the model rather than helping it. Wrapping up, 2 key takeaways stand out. First, curated skills allow smaller, efficient models to rival massive ones, effectively substituting procedural knowledge for raw parameter count. Second, the failure of self-generation confirms that for now, human expertise is essential to scaffold these agents in specialized domains. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.